Good morning, everybody, and welcome to our first ever at-home edition of Chabot Space and Science Center's live science show. Woohoo! I'm Haley, and I'm a science educator here at Chabot Space and Science Center, and today I'm actually coming at you live from my own house. So we're going to bring science from my home to your home today and kind of show you some ways that you can do some really fun experiments at home or at school if you're with your students. But this is kind of a way to show you how you can really bring science into your homes these days by literally bringing it to you from home. So I hope everyone out there is doing pretty good today. I hope that you're all staying safe and that you are mentally and physically happy and healthy. During this time, Chabot Space and Science Center is not open to the public, but if you would like to help support our mission to continue to bring virtual programming, such as our weekly live science show, our weekly live telescope viewings, and our other public programs, feel free to donate and support by clicking the donate button if you're on Facebook or heading to our website, chabotspace.org, and you can donate there to help support all of our free virtual programming that we're providing during this time. So what is live science? If you're tuning in for your very first time, welcome. If you're returning, welcome back. Happy to have you. Live science is a pretty fun little time where we get online and we do one live demonstration of a phenomena of science. So that could be a happening or an occurrence or a reaction. That's all due and explained by science. But I give you almost little to no explanation as we set it up, and I need you, all of my audience out there, to help be the scientists. So I need you to help me figure out what's going on, to make your best scientific observations, and to also help me out by trying to make some guesses of what you think is going on while I'm leading our demonstration for today. The way that we like to do that is by using the chat feature. So if you're joining us on Facebook or on YouTube Live, I've got my chat right up here ready to go so I can see what y'all are saying, what you're guessing, what your scientific explanations are while we do some science. And today, we're going to be switching it up. Because I'm coming to you live from home, we are not going to be doing a demonstration on sound, but on a little bit of some different science, but I promise should still be very fun, and I've got all my gear ready for all of you. So go ahead and type a little hello in the chat, warm up those little chat science fingers, and we're going to get going, and I'm going to need your help to make some observations and some explanations and some predictions of what you think is happening, what you think the science is, and you know, if you've seen something like this before, help us out. Help me explain it to the group. All right, so today we are going to do a demonstration using a few very simple household materials. The first thing that I'm going to get is this absolutely giant plastic bag. It's really big. This is bigger than like a regular plastic bag. And I'm going to pour a liquid in it. If you have a guess on what liquid I'm using, it's clear, you can drink it, you could shower in it. It's not apple juice. Although if you could shower in apple juice, that'd be kind of fun. Oh, I have someone in the chat saying they want me to show off my cool shirt. It is a little warm. I'll take my flannel off. I've got my cool Oaklandish and Chabot Space and Science Center shirt on. All right, so we're going to take this clear liquid that you can drink. It's water. We're going to pour it into my big, giant plastic bag. And I'm going to do a few things to my water. I'm going to try not to explain much, but I'll have you kind of guess what's going on while I do it. So the first thing I'm going to do is I'm going to take my bag and split it about halfway by placing it on top of this bottle that I have. So now I have two little pockets of water. And then I'm going to take some of this, and I'll get up and show it to you. I won't explain much, but you might have a guess of what this is. You can find it in your kitchen. You can make a quick observation. What color is it? What do you notice about it? Do you recognize it? What do you think this material is? If you could taste it, it is edible. What do you think it would taste like? And I'm going to take some of this white mystery ingredient. We'll see what your guesses are. I'll check in a minute. And I'm going to pour it into one side of my bag of water. So I'll pick one pocket. We'll do this one. And I'll try to gently pour some of this in there. And then I'm going to mix it up. While I mix it up, I'll check on your chat and see, what do you think this white liquid is? Or this white, could be salt, it could be sugar. Whatever it is, I'm going to mix it up until it dissolves all the way in the biggest bag possible. I feel like I'm reaching so far down here. Ooh, what is this all about? We're learning a little bit about, trying to think of how I can explain it without giving too much away. We're learning a little bit more about molecules today, a little bit about composition of liquids, and you'll see in just a minute exactly what we're talking about. All right, so now I have my two pockets, and I'm going to add some food coloring in this one, and this is where I'm going to need your help to help make some observations of what you notice. So I've got regular water on one side, and I've got this water that I've mixed an ingredient in on the other. And what I'm going to do next is I'm simply going to lift it up off of this bag, and I'd like your help to make some observations of what you notice between these two different pockets of water. And I'll actually add some yellow into this one so we can see. It's a little hard with my background. All right. Now before I lift it up, we have this pocket which had some of this white ingredient mixed into it, and I'll give you a hint, it's salt. And we have this side, which is plain water, has had nothing mixed into it. Now, before I lift this off of this bottle and let these two mix together, do you have any predictions of what will happen between this pocket over here, which has salt in it, and this pocket over here, which has regular water in it? As I lift it off of the bottle and allow these two to mix, do you think that they'll mix, or do you think that they'll do something different? A little bit more in. We've got a guess from Jeremy saying that the salt water will be heavier. Combustion? That would be pretty wild if we had combustion. Ooh, is it going to change to green? That's a good guess, actually. If it dissolves, it's salt, it is salt. All right, let's see what happens. So slowly, I'll lift it up, and then I'll ask for you to help me make some observations. Now, what do you notice between our blue water, which is the water with the salt in it, and the yellow water, which is the water that had nothing in it? Salt on the bottom, we're seeing green, not purple. If I had red and blue, we would have had probably purple. So what do you notice? Did these two liquids mix together? Did they separate out? And how did they separate out based on what you're seeing? And do you have a guess why? And I saw someone already type into the chat earlier, kind of a prediction and a guess ahead of time. Salt water is heavier, so it's making it sink. Yeah. So when we do this little short demonstration, which you could easily do at home, we have our blue water on the bottom, which is salt water, and our clear water, our plain water on the top, which is fresh water. And this all has to do with the concept of density. Now, if you can try to explain density, go ahead and type it in the chat. But we could think about density as the amount of stuff that's packed into one space. When you think of an object that has low density, it has just a low concentration of materials packed into it. So you could think of density as in a room. If you have a room filled with 5 people, it's a pretty low density room. There's not that many people in there, there's a lot of space, you can move around. But high density means that you have a lot of things concentrated at a high concentration in the same amount of space. So if you took that same room and filled it with 30 people, that's a much higher density space than it was before. So density has to deal with the concentration of the amount of stuff in a given volume. Now, because we had a given volume of water, we had about equal parts of each. We had more salt packed into our salt water, meaning that the salt water was more dense, and therefore it had a higher concentration of particulates in it, and that causes it to sink lower to the bottom. Whereas our fresh water, it still has stuff in it. Fresh water has lots of other things in it, like salt and minerals and whatnot. But because it's less dense, it tends to go up to the top. And eventually, if I were to just shake this up, it will mix together because these two liquids are the same, and eventually we'll just get a green liquid that's all kind of slightly salty. So, what does this have to do with anything? They are socially distanced, yes. And you may have noticed before I even mixed them that the middle of the two was starting to turn green. So one of these was saltier than the other, but not by much. So eventually those two different densities, they tend to kind of mix together, and that can easily happen. But at the beginning, that can cause that separation of those layers. Now, are any of you from the Bay Area, or do you live near a bay of sort? Because if you do, this is the same thing that's happening in the San Francisco Bay. The San Francisco Bay is what's called an estuary, which means it has an inlet of fresh water coming from all of our creeks and our local streams that feed out into the San Francisco Bay, bringing lots of fresh water in. And it also meets the ocean, the Pacific Ocean, which brings in salt water. And as the fresh water and from the creeks and the salt water from the ocean mix together in the San Francisco Bay estuary, it actually creates a bit of a separation of those two different densities. The salt water from the ocean is a little bit more dense and tends to go towards the bottom of the bay, and the fresh water, which is less dense, tends to float more towards the top. And then you have this kind of mixing zone in the middle where the fresh and salt are mixing together. But you do tend to see saltier water towards the bottom, fresher water at the top. That can kind of change what kind of animals you're seeing where, because some animals like saltier water, some animals like more fresh water. But the San Francisco Bay, which is an estuary, has that same thing happening inside of it. If you live along the coast, you probably live near some sort of estuary that same thing is happening. All right, so thinking about this whole density concept, I have two containers, one with salt water and one with fresh water, and you may have seen the classic experiment, but I'm going to drop an egg in each, and we're going to see what happens. So we'll drop an egg into our salt water and an egg into our fresh water. Now, what do you notice between these two different cups and these two eggs? What is the difference between them? Remember, this one was salt water and this one was fresh water. And what does this tell us about the waters or about the egg and how they're interacting? Put them down so I can check our chat. You can definitely try this at home. Yeah, if you live near the bay or if you live in Oakland, you can try to make some observations of what you're seeing. So the density helps suspend the egg. So we see the egg floating in this one, which has salt water in it, but the egg has sunk in this one, which is just fresh water from the tap. this is like the Dead Sea. The egg in the fresh water is still fresh. This is how you test your eggs. Interesting. All right, so in the fresh water, our egg has sunk, and according to our chat, the fresh water makes the egg sink. Well, what does that tell us about the density between the water and between the egg? Which of these objects do you think is more dense, considering the fact that when we did our fresh and salt water sank, fresh water stayed at the top. So is this egg more or less dense than salt water, or than fresh water? And over here, the same egg from the same carton is floating. So what does that tell us about the density of the egg versus salt water over here? Which one has a higher density? Which one has a lower density? The salt is more dense, so it can carry the egg, and the fresh water is less dense, so the egg sinks. Density is higher in salt water. Yep. Pretty simple. So if you were to go to a place like the Dead Sea, if you've never heard of the Dead Sea, it's a sea that's in the Middle East? Where is the Dead Sea? Type it in the chat if you know. But it's this sea that has a really, really high density of salt. It's a super, super salty sea. And if you were to go there and swim in the Dead Sea, because the water is so salty, it has such a high density that you, as a human, even though you might weigh, you know, anywhere from 50 to 100 to 200 to 300 pounds, whatever you weigh, you're going to be less dense than the Dead Sea because it has so much salt water packed in it. And then you float. You can basically just like lay down and float in it. I've never been there, but I've had friends who've talked about it, say it's really cool. So the different oceans around our world have different salinities and different densities, which can affect the rate at which things float and which things sink, could affect animals. If you were a fish and you affect your buoyancy based on the water that you're in, if you're in saltwater versus freshwater, you're going to have a different type of interaction with that environment than you do versus the other one. So when we look at this kind of experiment, this is really good at helping us figure out densities between saltwater, freshwater, eggs, and whatnot, but it also has implications for the real world of how we navigate through different types of waters and how other organisms interact with that. Thank you. The Dead Sea is between Israel and Jordan. Thank you so much for our friends out there who are much better at knowing where things are than I will ever be. Appreciate you all. Oh, Eric, hi. He remembers floating in the Great Salt Lake in Utah. So Utah also has a really salty lake that people can float in. It's really cool if you ever get a chance. I definitely felt it when I've been to other places around the world that have different salinity oceans. They taste saltier, but they're more fun. Okay, so last demonstration we're going to do about density. It's a classic. We're doing the classics today because we're at home. So I have one material over here, one material over here. This is water, this is oil. We're going to mix them together. But first, I'd love to hear your predictions. Which one of these materials do you think is more dense or less dense, and why? Do you have previous experience that has led you to knowing that? Do you just know it? Why do you just know it? How do you just know it? Really think back, you know? We can assume science and its validity and its truth many times in our life, but let's think about the real world examples that we've seen that explain why one of these is more dense than the other. Oh man, we're in a great conversation in our Facebook chat about salinities. All the Mediterranean Sea is extremely salty. In fact, you have lots of salt plains on the islands countries there. Alrighty, so let's see. Oil is less dense and it will float. Oil is less dense, and Erica, you know that from baking. Really good experience to draw on, thinking about those two. Oh, someone asked in our YouTube chat, does juice have a high density? That's a good question. I'm assuming yes, because it has more stuff in it. Sugar can increase density, but also whatever the fruits are that you're doing. It's mixing water and juice from other fruit. So I would assume that juice is more dense than water, but it's a good experiment. You should try that one at home. I don't have juice with me right now, unfortunately. All right, so let's see. Oil is more dense, so it should float on top. Let's see. By doing that, I guess we'll put our water first. All right, so we've got our water, and if all is right, mix them together. All right, so based on your predictions and based on the observations we can make, our yellow oil has gone to the top and our blue water is staying at the bottom. That tells us, based on what we've been talking about, that water or oil is less dense than water because it's gone to the top. It's a little bit lighter, floats, and that water is more dense than oil, so it sinks to the bottom. Now this is really interesting because this has implications for things like an oil spill. When an oil spill occurs out in the oceans, a lot of that oil is less dense, so it floats on the top like this. But it can be really challenging to remove from our oceans. Even if I were to mix this up with a spoon, it kind of breaks the oil up into even smaller pieces, but we still tend to get that separation between oil and water. But if you've ever seen pictures or images of something like an oil spill, and you'll often see animals that live at the top of the ocean, like birds, like water birds, pelagic birds who are, flying across the oceans and needing to rest, any of that oil that's at the top of the water is going to be affecting the animals that live up there even more, or animals that come to the surface at any point. So this can help scientists study kind of the different densities and how that oil is going to react with the rest of the water that we're seeing out in our oceans. And over time, if I were to just leave this, we would eventually see this oil kind of break back down into one big blob. Right now I've kind of broken it up. There's a lot of air in there. Are there any other implications or applications that you can think of how density can help us in our lives day to day, or can help explain certain things that we see in our lives day to day that you can think of? Think about it. If there's any other applications, explanations. And if you have any questions, feel free to type them into the chat. What happens when I put water on top of oil? That's a good question. We can try that out. So while you think of other implications, other ways that density can help us navigate the world or explain the world, let's see what happens when we do the opposite. I'm just going to pour some water from my egg, because that's what I've got. So we have our oil, and we have our water, and when I pour, should I do this a different color? That would make sense, right? Let's do red. Sorry, egg. Okay, so now that we can tell the difference, we've got our red water that we're gonna pour in to mix with this to see how they interact. So let's pour some in. Interesting. So what do you notice? That's weird. Interesting. What did you notice when I poured them together? Now that we're seeing them, I'll hold it up a little bit closer. So we've added more water in to our oil and water situation. Any cool observations that you've made? I've got some, but I'll wait for you to share any that you have. Real quick. Gotta clean this food coloring up. Okay, so some of the things that I noticed was that when I poured the water in, the first thing that we saw was kind of that mixing of the color. So these two waters were obviously mixing together, which we would expect, and it was sinking to the bottom. So it wasn't really staying on top because it is more dense, so therefore it's going to the bottom. But we also kind of saw that interesting mixing happening, and even right now I can see there's still a little bit of that red water up at the top. So maybe that hasn't mixed in fully, but as I poured it, it kind of mixed up the oil a bunch and caused the oil to move in an interesting way. So we get that temporary mixing of these two materials, but eventually, because their densities are so distinct and so different, they do end up splitting back out, and the water that has the same density as the other water has stuck together. So, interesting. Good question. Yeah, a little bit of that red has stuck around. It didn't turn as purple, I know, it's a bummer. But the good news is, everything that we did today you could do at home, and you could do it with different materials, different colors. You can add in other density materials. You could add in honey, you could add in milk, you could add in soapy water, you could even add more salt water in. My cup is a little full, otherwise I would put salt water in it right now. So you can kind of try this out at home, and you can try to put different materials if you want to test out something besides an egg. What else do you think you could test in something like a density test like this? And then you can think more on, what is this telling us? What is this doing for us? How could this application be important in space if we ever go to space? What is density going to mean when we go there? So those are some challenges that I'm going to leave with you to do at home, especially if you are staying at home and you are looking for something to do. This is a great little fun thing to do that I like to do in my free time. All right, friends. So if you have any questions, feel free to type them into the chat. But as we wait for you to type those in, I just want to let you know that live science we do every week. We will be joining you again next week, here, same place, same time. And we will be taking the week of the fourth week of November. There will be no live science on the 25th of November. We'll be taking a little break, but then we'll be coming back in the first week of December. So just a heads up that that's on the way. And we also have some other events coming up. We have weekly live telescope viewings where you can join some of our volunteers who are excellent astronomers, excellent observers on the weekends. Typically we have telescope viewings Saturday evenings around 9 p.m. or 8 p.m. And you can join those on Facebook Live, and you can, look at the stars virtually. It's pretty cool. And we also have some fun talks coming up with some partners, so feel free to check our Facebook page or ChabotSpace.org for our event listings that are on the way. And once again, if you want to help support any of our programming that we're doing, go ahead and click that donate button. Thank you all so much in advance if you are supporting. If you're a member, thank you for sticking around. We appreciate you all a bunch, and yeah, I'm going to check questions. Exactly as expected, of course. Yeah. So Jeremy asked a good question, which I've always been kind of confused about, is that if you hold a cup of oil and a cup of water, oil feels heavier than water, but yet it's less dense and it floats. So I have no idea what's going on there. It could be the way that the molecules of oil are kind of packed together that causes them to spread out, but yet it still feels heavier, but I'm not exactly sure. So that's a really good question, and now I have something to look up after this. Good question. Once again, I cannot. Excellent. Ooh, what's the lowest density liquid known? I don't actually know. I think water's pretty high up there, but... Oh, we've got Chabot Space and Science Center on it. So common liquids, so gasoline is actually 30% lighter than water. and there's some other compounds used in science that are much less dense than water. So there are other liquids out there that are less dense than water. I just don't know if I have any like in my house. Like what would be a household one? Which would be interesting. Good question. All the questions today just have me going, I don't know, which is great. That's the best part about science. When you don't know something, you can look it up, you can go investigate it at home, you can look into it yourself, but there's definitely some less dense liquids. Thank you to our chat monitor, Olivia, for helping get on that question. Love it. Any other questions that we've got? Liquid hydrogen, that's actually a really great guess, or really great, not guess, but answer. There are other liquids that we don't even have occurring naturally on planet Earth. So we have liquids that we can find, like water, and liquids that we can make, like juice. But there are liquid elements that can be made using specific elements on the periodic table, like hydrogen, which have basically just hydrogen in them, which is probably less dense than water, which would be hydrogen and oxygen. So that's actually a really great one. Thank you so much for getting me to think of that. Where did I get this big bag from? Great question. It's from a camping trip. When you go backpacking, you have to make sure that you can't get all your food wet. You don't want it to smell, to attract animals. So I got it at an outdoor store. And it's really big and it's really sturdy, and I've had it for a few years. So if you need a giant plastic bag that's going to last you a little bit longer, an outdoor store is good for backpacking. Or you can get a reusable bag, like a silicone one, if you want to have a better environmental footprint, which we're working on. All right, folks, thank you all so much for joining us. Thank you for joining me here in my home today. I appreciate you all for participating in our chat and for helping me explain these things, because science is a lot better when we can help do it together. And I really appreciate you all for showing up. So thank you so much. We will hopefully see you next week. And, you know, stay safe, stay curious, do some experiments, let us know how it goes, and we'll see you next week. All right, thanks.